Now I'm going to have you watch Jun Shou and do her intensive intervention. She's working with a student named Esri, and as you can see here, Esri is solving this problem. We actually saw this video, the first part of this video, in another module. She's solving the problem 204 minus 167. And that's a difficult problem because students have to regroup across 0, which often causes a lot of confusion and difficulty for students. So now we're going to see Jing Shou teach the procedures for solving a problem such as this. She's also going to combine that with concepts. So this is not strictly a procedural lesson, but it's also a conceptual lesson as well. Now, I'm not going to point to these this time, but as the video goes, I want you to see where explicit instruction is coming into play, and it should be everywhere, all right? I want you to see how multiple representations are being used, and here's a little clue as to what we might be doing there. And I also want you to pay attention to the concise language that's used within this video. So we're going to watch the whole thing, and then when we come back, we'll debrief to think about how were the concepts and procedures of whole numbers emphasized in this lesson.
I told you this problem is a little bit tricky, so that's all right. We're going to use the base 10 blocks to help us, all right? So have you ever used them before? Yes, good. So first, we're going to write hundreds, tens, and ones column here. Alright, so these little cubes are our ones. One cube represents 1. Good. And one rod represents 10. Good job. And one flat represents 100. Good job. But I have a harder question for you. Do you know how many tens are there in 100? 10. Good, because there are 10 groups of tens, right? Alright, so now first let's look at the number we start with. We start with what number? 200. Good, 204. Sorry, 204. So can you tell me how many hundreds are there in 204? 2. 2. So how many flats do we need? 2. 2. Right. 1, 2, and I'm going to write 2 here. And how many tens do we need? 0. 0. So we don't need any rods here. All right. So how many ones do we need? 4. So can you count 4 cubes and put them in the ones column? Good. So what number did we show? 204. Okay, so can you write 4 here? And we have 0 here, right? Can you write 0 here? So it's 204. All right. So now we're going to do the subtraction. What number are we subtracting? 167. Good, 167. And where do we want to start? We start with the ones place, right? So we have to subtract 7. And how many do we want to take away? 7, right? We have to take 7 away from 4. Can we do that? Can we take 7 away from 4? No. So what do you think we should do? Maybe we can exchange something for ones, right? But do we have any tens here to exchange? No. So maybe we have anything else to exchange? Do you think we can exchange the 100 into tens? Right. So let's count 10 rods here. 1. Do you remember we said how many tens are there in 100? 10. 10 tens. Good. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we can exchange 100 for 10 tens, right? So we exchanged 100 for 10 tens. Now, what are we going to do? we still only have 4 cubes, right? So we have to exchange 1/10 for how many ones?
10.
10 ones. 10 1. Okay. 5, 6, 7, 8, 9, 10. So we exchanged 1 rod for how many cubes?
10.
10. Okay, so can you tell me how many ones do we have now?
14.
14, good. So we have 14 cubes here now. So do we have enough to subtract 7 now?
Yes.
Yes. All right. So let me write here 167 here first. And can you take 7 away from 14? All right, go ahead. All right, so we take away 7, and how many left?
7.
7, good. So, actually, yeah, so we take 7 away from 14. So now, how many do we left?
7.
7, so can you write 7 here? Good. Right. So now we only have how many 10s here?
9.
9. So can you take away 6 rows here? All right, can put here. So how many rows are left?
3.
So can you write 3 here? Good. So we have 100 here, and we have to subtract 100, right? So what are we going to do? We're going to take away 100, and how many left?
0.
0. All right. So we have 0 left, but actually we don't need to write 0 here, right? So our answer is
37.
37. Good. But let's check whether this answer is correct. So if this answer is correct, when we add 167 and 37, it would be equal to 204, right? So can you check the answer? So you're going to add 167 and 37. Alright, so is our answer correct? Good.
All right, so Jing Shou did a really nice job with this lesson. I'm not going to point it out this time, but she used tons of explicit instruction. This was a lot of guided practice with the student. This was the part of that lesson. She was working with the student was frequently responding. She was frequently moving things around. Jing Shou was doing the writing, but then the student did the writing. Lots of nice explicit instruction going on there. We have the multiple representations, both the abstract form of mathematics, and here we have the concrete form of mathematics. I would almost always say we kind of have a representational thing here with our hundreds, tens, and ones column drawn on the table. And then she did a nice job with her concise use of language. One of the things that I thought was excellent is that she did not describe regrouping as borrowing. She described it as exchanging. So if an exchange of 10 ones for 110 or 110 for 10 ones and that type of thing. So really nice, consistent use of concise language. But why we watched this video here was to think about what were the concepts and procedures of whole numbers that Jing Shou focused on. So I made some notes. I've got my notebook here. I'm going to write it down because I was watching the video just as you were watching the video. But in terms of concepts, well, the first thing that I saw that Jing Shou emphasized was understanding base 10 and the base 10 blocks, and that these are represented by hundreds, tens, and ones. And she did a nice job of giving a student a visual for the place value. Oops, I'll write tens there. The place value that goes with hundreds, tens, and ones. ones. She did a nice job of talking about these as flats, rods. She did call those cubes. We talked about that in a previous module. That's okay if she uses that consistently. And she did a nice job of talking about exchanging. So I have 10 tens and 100. That was, I think, the example that she gave. And this exchanging, she was using the word exchanging, but she's talking about regrouping. But these are all conceptual ideas, so you have to understand our numbers in base 10, have to understand how numbers can be represented by hundreds, tens, and ones. And then she did a nice job, and this was throughout the lesson, of emphasizing the exchanging or the regrouping. Now, the thing that Jingshou did a lot on were the procedures here. So they were working on this subtraction problem. So I would just kind of put these out here. So she talked about first they're going to start with 204. So she wanted to show the, what is that in that number? Is it the minuend or subtrahend? It's the minuend. So she started with the minuend of 204. And then she had the student show the hundreds, tens, and ones, or as here she called them the flats, rods, and units. So getting this problem, or she didn't call them units, I called them units, she called them cubes. I'll go ahead, well, I want to write units because I feel like that's the more correct way to talk about those, and that's what will be in your memory. So then she did the procedure of showing these, and then they did the subtraction. So then, well, wait a minute. Yes, so then she talked about that they need to subtract 167. And the procedure of what did that entail, kind of put that down here, is first they subtracted the ones. So now I, of course, subtracted the ones. And this is where there was a regrouping. So that's always good to check if you have to do that. And remember, she didn't call that regrouping. She called that exchanging. Means the same thing. Then Jingshou and Esri, they subtracted the tens and talked about a regrouping necessary there. And then finally, they subtracted the hundreds. So look at this procedure that Jingshou is teaching. It's quite detailed, and this is not the simplest of problems, but there's quite a bit going on here in terms of what she's thinking about in terms of the procedures. And then what I liked is that once they solved the problem, she reviewed the answer, and really importantly, Jingshou, the last thing she did is they checked their work. And how did they do that? They did it by using addition. And I'll kind of scoot in front of that so now you can see it just a little bit better. So the idea here was that if we're doing intensive intervention, and we're focused on, here it was computation for multi-digit numbers. We have both the concepts that we emphasize to the students, and then we have the procedures that we emphasize to the students. And Jingshou did a really nice job of doing this, all of these things. This was her instructional platform. It was teaching about computation. She emphasized both the concepts and the procedures that we've talked about earlier in this module, but then she employed things that we've talked about in previous modules. So using explicit instruction, using multiple representations, being concise with her language.